Hello and welcome to this third algorithm selection and development lecture in this course Master in Artificial Intelligence. So in this particular lecture, as a part of how to research, select and develop appropriate algorithms, we will talk about how to determine the type of output and evaluation matrices specifically for regression and clustering type of outputs. So how do you think you can determine regression and clustering type of outputs and the corresponding evaluation metrics? Any thoughts? Let's. So the regression tasks involve predicting continuous numerical quantities or values, right? And some of the examples I may like to tell you is you can correlate to that is if you need to predict housing prices or stock price forecasting or demand forecasting. And to determine, how can you determine? To determine if problem is a regression task, what you need to do is to check if the target variable consists of continuous numerical values. That's how you can determine whether a particular output is of regression type or not. So what are the evaluation metrics for regression type of output? Let's take a look at them, and I'm going to talk about four of them here and explain one in more detail. The first one is, is the mean absolute error, MAE, mean absolute error. It's an average of absolute differences between predicted and actual values. So that's what is called a absolute error. Second is what is called mean squared error, where the average is taken of the squared differences between the predicted and actual value. Then there is the root mean squared error, where you take the square root of the previous one, which is MSE, which provides a measure of average prediction error in the same unit as the target variable. The squares could be different. So taking a root mean square, it brings it down to same unit as the target variable. And the last one is a R squared, which is very often used, that measures the proportion of variance in the target variable explained by the model. So shows effectiveness of your model because this large proportion of variance of the target variable explained by the model, then you have a good model. Let us look at R squared score a little more. R square is a percentage of variance, as we were talking about, within the target variable that is represented by the features in a model. And as you see here, the formula and the details on your screen, you may need to come back and look at this by downloading this in the PDF file. A high R squared close to 1 indicates the model fits the data well and frequently makes a correct prediction. So high R squared is a measure of effectiveness of the model being predictable more so. So let's look at what does clustering involve. Clustering involves grouping, similar data points together into clusters, into groups based on their features or characteristics. So there are features and characteristics and your model is able to do and put them together and also tell you what those features are. Now, some of the examples that may strike chord with you are things like, customer segmentation, document clustering, and image segmentation. In customer segmentation, you put the customers of similar type based on certain feature or characteristics together, same in document and same in image clustering. Now, how do you determine if the problem is a clustering task? You need to check if the goal is to identify natural grouping of patterns in data without predefined labels. So you don't have the labels, you just have the data. And you need to identify such natural groupings of patterns in the data. That is the purpose, and that becomes a clustering task, right? So what are the evaluation metrics for a model that does clustering tasks? How do you figure this out whether this model is doing right things? What are the evaluation metrics? And there are a lot of new things here for you to see. The first one for the clustering evaluation metrics is what I call Shillot score, which measures how similar an object is to its own cluster compared to other clusters. So how much does an object belong to the cluster, the own cluster compared to other? Second is a Davies Baldwin index, which computes the average similarity between each cluster and its most similar cluster. So that's second kind of a thing. Third one is an adjusted RAND index, ARI, or adjusted mutual information index, which measures the agreement between the true labels and cluster assignments. So there are, when you're predicting some of the items you would assign to a cluster versus if you know the labels. So how true is the label versus the assignment? So predicting accuracy is get determined by ARI and AMI. So that's what these some of these evaluation matrices are. So what is next? So we will now look at each of these in a lot more detail. What these are, starting with Silhouette score. How does it measure how similar an object is to all clusters compared to other clusters? And then we go on in further lectures talking about the other two evaluation metrics as well. So thank you so much for watching this third algorithm selection and development lecture and this course Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy. And I do look forward to see you again in the next lecture. Please do feel free to download please feel free to message me if you have any questions and also download the PDF file and take a look at some of these things that we have been talking about.